Alright, now that we've seen how to take the derivative of a natural log, let's look at how to take the derivative of a regular log. So we're going to have d over dx of log base b of x. Now what we're going to do is we're going to split this log into something that we already know. It's like the derivative of the natural log. So we can rewrite this log base b of x as, let's write it over here, log bx is the same thing as me saying natural log of x over natural log of b. So now when we do the derivative of this, we see that because we have a fraction right here, we're going to need to do some quotient rule. So doing the quotient rule, that means that I'm going to bring my natural log of b up to my numerator, so ln of b, and we're going to multiply by the derivative of ln of x, which we saw in the last video is simply 1 over x. Then we subtract. Now ln of x will stay the same, so we have ln of x, and then we take the derivative of the natural log of b. Now in this case, b is my base for my logarithm, which is just going to be a number. So the natural log of a number is just another number, so its derivative is going to be 0. I put that all over ln of b squared. So simplifying from here, let's get a new color. I'm going to have natural log of b times 1 over x, so I'll just put this over x, minus ln of x times 0, that's just going to be 0. Let's extend my division line. I have a natural log of b squared on the bottom. Simplifying from here, I see that I have a natural log of b in my numerator and a natural log of b in my denominator, so they will cancel on top and reduce on bottom. So that's going to leave me with 1 over x ln of b. Alright, so that's the case if this was ln base b of x, but what if I had not ln, log. If I have log base b of x, and now I'm going to have log base b of some function of x, let's call it u. Now when I take this derivative in terms of x, it's going to be very similar, but a little different. It's still going to be 1 over, let's see, it's not going to be x anymore, it's going to be u. So this is my x part, and it goes down here. This is my u part, and it's going to go right here. It's still going to be times the natural log of the base, but now because I took a derivative of u, and u is a function of x, I need to use some chain rule and multiply this by du over dx. Now that we've seen how to take the derivative of a log, let's look at how to take the derivative of a constant to a power that has a variable in it. So let's have a constant, let's call it constant b, and it's going to be put to the x power. So the question is, how do I take this derivative? And the answer is that we're going to be using the log techniques that we just used previously. This b to the x power is going to be equal to some y value. So I can transition this exponential statement into a logarithmic statement using some properties of logarithms. So this changes into log base b of y equals x. Alright, and from here, we're going to be taking the derivative of a regular log just like we just did. So we know that the derivative of log base b of y is going to be 1 over y ln b times dy over dx. And this is going to equal, the derivative of x is just going to be 1. Now one thing you might notice or ask yourself is, where did dy over dx come from? And this is similar to when we did the log of base b of u, is that y is a function of x, so when we take its derivative, it needs chain rule. Chain rule. Alright, so from here, we want to get dy over dx by itself, because that's the derivative that I'm looking for. So what we're going to do is we're going to multiply both sides by y ln of b. So that's going to get me dy over dx equals y ln b. And now looking back at my substitution earlier, I said that y equals b to the x power. So therefore I can substitute that back in, and my derivative will be b to the x power times the natural log of b. Now something we can notice from this equation that we just created is that we're going to have a special circumstance happen when my constant b is equal to the natural exponential function, otherwise known as e. So if instead of b I write e, and I have e to the x, then this derivative, if we follow the formula we just created, is going to be e to the x times the natural logarithm of e. The natural logarithm and e are inverses, so this actually cancels to 1, leaving you with just e to the x. And this is why e to the x is special, is that its derivative is itself.